Hi guys, welcome to my channel. Today we're going to be learning about the mole. So in this topic, what we're going to learn about specifically is that we're going to use Avogadro to determine the number of particles in a given number of moles. So basically, if we're given some number of moles, we can calculate how many particles we have using this amazing thing called Avogadro. So the first thing we're gonna learn the concepts. So small particles like atoms, molecules, or ions, all of the small particles can be counted using moles. And the unit for moles is Avogadro. And so we have something called a conversion factor that we use to calculate the number of particles when we're given the number of moles. So we have the conversion factor as 1 mole is equal to 6.02 multiplied by 10 to the power 23 molecules. So you should memorize this because it's very important to solve problems. And so we're going to be solving some questions, and these are the common questions that I always see. So the question says, how many carbon dioxide molecules are in 0.5 moles of carbon dioxide? So the first thing that I always do is write what I know. I know that 1 mole has 6.02 multiplied by 10 to the power of 23 molecules. That's what I know. Now I read the question and I write what I'm supposed to be calculating and what I have. So how many molecules is your X, because you don't know about that. And you know that you have 0.5 moles. So you write, okay, moles with moles goes here. And you need to know X molecules. So now what you do is you cross multiply it. So you write 1 mole multiplied by X is equal to 0.5 moles multiplied by 6.02 multiplied by 10 to the power of 23 molecules. Right? The 1 goes there by dividing it, and so you get X as 3.01 multiplied by 10 to the power of 23 molecules of carbon dioxide as your final answer. Another common question that I see is they ask you how many number of moles you have of something by giving you the number of atoms. So again, you write what you know. You know that 1 mole is equal to 6.02 multiplied by 10 to the power 3 molecules. And now they're asking you how many number of moles. So that's your X. So X goes here. And this is what is given. So 1.8 multiplied by 10 to the power of 23 atoms or molecules is the same thing. Now what you do is you cross multiply again and you calculate it in that way. So you write everything down. It's equal to X and 6.02. Sorry, I don't have space, but you know what the units are. This goes there dividing, and so you get X to be as 3.0 moles as your final answer. Now in this case, I want you guys to also know that this is an important topic, the moles of elements in a compound. So they're pretty important. For example, a compound is any formula that has many elements such as aspirin. We'll take that as an example. Aspirin is C9H8O4. So these things right here, the numbers, they are called subscripts. And these are important because, first of all, they show you the relationship of atoms. And second, the one that in this topic we're concerned with is that it gives you the moles of each element in 1 mole of a compound. So it's very useful. You'll see it in the next question that I'm going to show you. So it basically tells us that in 1 mole of aspirin, we have 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. So using this concept, you'll see why it's important in this question. So it says, how many atoms, that's your X, of oxygen are in this much moles of aspirin? As I said, aspirin is a compound, C9H8O4. Now they're asking you specifically for oxygen, so this one is important right here, the O4. So remember what I told you? There are 4 moles of oxygen in 1 mole of aspirin, so that's what you know. You have to write it down. So you know that there is 4 moles of oxygen in 1 mole of aspirin. And by reading the question, you also know that there is 0.150 moles of aspirin. So you write it down here, moles with moles. Moles of aspirin. Now, in order to calculate the atoms of oxygen, we need to know the moles, right? So we can use, so we put X moles to calculate the moles. That will make me be able to calculate the number of atoms. So you will get, by cross multiplying, but that X is 0.6 moles of oxygen. Now you have moles. You're ready to go and write this conversion factor here. That 1 mole is equal to 6.02 multiplied by 10 to the power of 23 molecules. You have this, so you write it here, 0.6 moles, and you need to know how many atoms or molecules there are. So by cross multiplying again, you will get X as 3.61 multiplied by 10 to the power of 23 atoms of oxygen. So that's how you use these concepts right here to calculate the number of atoms, and you can also calculate how many moles you have if they give you the number of atoms. So that was it for topic 1. Please subscribe for more videos. The next video will be on molar